Welcome viewers, let's see what is airspace. In this video, as we all know, our Earth is surrounded by layers of gases known as the atmosphere. Earth's atmosphere is the medium through which all aircraft operate, and its characteristics directly affect flight performance, navigation and safety. Earth's atmosphere is commonly divided into 5 main layers based on temperature and altitude. First layer is the troposphere, which extends from the surface up to about 8 to 15 kilometers, which is 25,000, 50,000 ft. This layer contains weather, clouds and turbulence. It is most important layer for aviation operations. Second layer is the stratosphere, and it extends up to about 50 kilometers, which is 164,000 ft. This layer contains the ozone layer. It contains stable air, ideal for high-altitude jet cruising. Third layer is the mesosphere, which extends up to about 85 kilometers. Meteors burn up in this layer and is of very low air density. Fourth layer is the thermosphere, which extends up to about 600 kilometers. It contains ionized gases and is important for radio communication. And satellites' fifth layer is the exosphere, which is the outermost layer. It gradually merges into space and contains very sparse air particles. Most aircraft operate within the troposphere and lower stratosphere, where lift, engine performance, and weather conditions are most relevant. Air density, pressure, and temperature decrease with altitude, affecting engine performance, lift, and aircraft climb capability. Variations in atmospheric conditions also influence true airspeed, altitude readings, and fuel consumption. Hence, commercial jet aircraft often cruise near the boundary of these 2 layers, known as the tropopause, to avoid weather and achieve fuel efficiency. Airspace is the portion of the atmosphere controlled by a country above its territory and surrounding waters. Each nation is responsible for managing its airspace in accordance with global standards set by the International Civil Aviation Organization. These standards ensure uniformity and safety in international aviation. Airspace is not just empty sky. It is carefully divided into sections, each with specific rules, communication requirements, and operational procedures. Without structured airspace, modern aviation would be chaotic and unsafe. Airspace classification reduces confusion and ensures that aircraft maintain safe distances, controllers manage traffic efficiently, pilots follow standardized procedures. Airspace management is critical for 4 key reasons. 1. Safety prevents mid-air collisions by separating aircraft. 2. Point efficiency organizes traffic flow to reduce delays. 3. Security protects sensitive areas such as military zones. 4. Coordination enables communication between pilots and air traffic controllers. Pilots must understand airspace classes before every flight. During flight planning, they determine which airspace they will enter, communication requirements, weather minimums, equipment needed airspace. Classification directly impacts flight safety and operational procedures. Airspace is broadly classified as controlled airspace and uncontrolled airspace. In controlled airspace, aircraft are under the supervision of Air Traffic Control, or the ATC. Pilots must follow strict instructions regarding altitude, speed, and route. In controlled airspace, ATC provides separation between aircraft communication, with ATC is usually mandatory aircraft operate under Instrument Flight Rules, IFR, or Controlled Visual Flight Rules, VFR. This type of airspace ensures that aircraft operate safely in regions with high traffic density. Next is the uncontrolled airspace. Uncontrolled airspace is where ATC does not provide separation services. Instead, pilots are responsible for maintaining safe distances from other aircraft. In uncontrolled airspace, no mandatory ATC clearance required. Pilots follow see and avoid principles, common in rural or low traffic areas. Although it is called uncontrolled, it still operates under aviation regulations. Pilots must remain vigilant and follow standard procedures to ensure safety.
International Civil Aviation Organization has standardized global airspace into 7 distinct classes, from Class A to G. Each class has specific rules regarding separation, communication, and flight operations, ensuring safe and efficient air navigation. Class A, Class B, Class C, Class D, and Class E are controlled airspace, whereas Class F and G are uncontrolled airspace. Although ICAO provides global guidelines, each country may adapt slightly different airspace classifications. However, the fundamental structure from A to G remains consistent worldwide, ensuring that pilots can operate internationally with a common understanding. Let's see each classes of airspace in detail. Each class of airspace is designed based on traffic density, operational complexity, and safety requirements. First is Class A airspace, which has the highest level of control. Class A airspace is the most strictly controlled category. It typically exists from flight level 180, which is 18,000 feet from mean sea level, up to flight level 600 in many countries. In Class A airspace, only IFR flights are permitted. All aircraft are under continuous ATC control. Full separation is provided between all aircraft. High-speed commercial jets operate in this airspace. Pilots must follow strict clearances, making Class A the safest and most regulated airspace. Second is the Class B airspace, which is in busy airport zones. Class B airspace surrounds major international airports with heavy traffic. In Class B airspace, both IFR and VFR flights are allowed. ATC provides separation between all aircraft. Entry requires explicit ATC clearance. It is highly structured, often shaped like an inverted wedding cake. Class B ensures safe operations in congested environments with constant arrivals and departures. Third is Class C airspace, which is in moderate traffic areas. In Class C airspaces, both IFR and VFR flights are permitted. ATC provides separation between IFR and IFR and VFR aircraft receive traffic information about other VFR aircraft. Communication with ATC is mandatory. This class balances safety and flexibility for mixed traffic. Fourth is the Class D airspace, which is controlled, but simpler Class D airspace typically surrounds smaller airports with control towers. In Class D airspaces, IFR and VFR flights are allowed. ATC provides separation only between IFR aircraft. VFR aircraft receive traffic advisories. Two-way radio communication is required. It is less complex than Class C, but still provides structured control. Fifth is the Class E airspace, flexible controlled airspace. In Class E airspace, IFR flights receive full ATC separation. VFR flights are not separated, but receive information when possible. Communication is required for IFR, but not always for VFR. Exists at various altitudes, often starting from 700 or 1,200 feet. Class E acts as a transition between controlled and uncontrolled airspace. Sixth is the Class F airspace, which is basically an advisory airspace. Class F is known as advisory airspace and is not used in all countries. In Class F airspace, IFR flights receive advisory service. ATC provides traffic information, but not full separation. VFR flights operate freely with basic advisories. Pilots are responsible for maintaining separation. Many countries are phasing out Class F in favor of more controlled structures. And finally, seventh is Class G airspace. Class G is completely uncontrolled airspace, usually found at lower altitudes in rural areas. In Class G airspace, both IFR and VFR flights are allowed. No ATC separation is provided. Pilots are responsible for see and avoid principles. Communication with ATC is not mandatory. Despite being uncontrolled, pilots follow standard procedures to maintain safety.
Now, having understood the 7 classes of airspaces, let's see the important building blocks of airspace. The world's airspace is divided into large regions called Flight Information Regions, FIRs. Each FIR is managed by an air navigation service provider responsible for providing flight information and alerting services. FIR services include 1. Flight information. 2. Weather updates. 3. Alerting services for emergencies. FIRs ensure continuous support for aircraft across long distances. The structure of FIRs and their boundaries are decided by ICAO in consultation with countries, as per their sovereignty. Next, let's explore the control area, or the CTA, in airspace. C2As are basically made to manage en route air traffic. Control area, or CTA, is controlled airspace that extends above a certain altitude and is designed to manage aircraft during the en route phase of flight. Key features of CTA are: does not start at ground level, extends from a specified lower limit above ground to a specified upper limit, covers larger geographic areas. CTAs are usually classified as Class A, C, or E. Airspace CTA ensures safe separation of aircraft cruising at higher altitudes. Serves as the bridge between airways, en route, and terminal areas, CTR-TMA. Managed by Area Control Centers, ACC, or Approach Control, APP, Centers of Air Traffic Control. CTA are located above the control zones, which we will see soon, or other defined altitude. What is the structure of control areas? Control areas can be large and continuous regions covering wide areas, segmented corridors following major air routes, connected to form airways or upper airspace systems. They often link multiple airports and FIRs to create seamless traffic flow. Then what are the types of control areas? Firstly is the terminal control area, TMA. A terminal control area, or the TMA, is a type of CTA established at the convergence of multiple air routes near busy airports. Manages arrivals and departures at higher altitudes, ensures smooth transition between en route and terminal phases. TMAs are commonly found around major international airports. Second type of control area is the upper control area, or UTA. Upper control areas are located at higher altitudes, typically used by commercial jet aircraft. Usually classified as Class A airspace only. IFR flights are allowed, provides full ATC separation. UTAs are essential for managing long-haul and high-speed traffic. Let's explore the third airspace block, which is a control zone, or CTR. A CTR extends vertically from the ground surface to a specified upper limit. Designed to protect IFR, instrument flight rules, arrival, and departure trajectories. Can cover multiple aerodromes and is managed by Approach Control, APP, or Tower. A control zone is a controlled airspace established around an airport to protect aircraft during takeoff, approach, and landing, the most critical phases of flight. The key features of CTR are CTR surrounds. One or more aerodromes. CTR extends from the surface of the Earth up to a specified altitude. CTRs are usually classified as Class C or Class D airspace, and they are designed to manage high-density traffic near airports. Thus, a control zone ensures that arriving and departing aircraft are separated and guided safely by ATC. What is the structure of a control zone? A typical CTR has a horizontal boundary extending several nautical miles around the airport. A vertical, limit starting from ground level up to a defined altitude, example from 2,000 to 5,000 feet. The shape may vary depending on terrain, traffic patterns, and airport layout. Within a control zone, ATC provides clearances for takeoff and landing, maintains separation between IFR aircraft, provides traffic information to VFR aircraft. Ensures orderly sequencing of arrivals and departures. Pilots must establish two-way communication before entering a CTR. Why do we need CTR, by the way? CTR is critical because aircraft are at low altitude and close proximity. Traffic density is highest near airports. Precise coordination is required for safe operations. Without CTR, airport operations would be chaotic and unsafe. Having seen both, let's now find the relationship between CTR and CTA. CTR and CTA work together to form a complete airspace system. CTR handles low-level operations near airports. CTA manages mid and high-level en route traffic. TMA connects CTR and CTA for seamless transitions. This layered structure ensures continuous control throughout a flight. Now come the fourth block of airspace, which is Aerodrome Traffic Zone, or ATZ. ATZ is a localized zone around one specific aerodrome, radius often 2 to 5 nautical miles radius. Extends from the surface to approximately 2,000 feet or 600 meters above aerodrome level. Protects local traffic, VFR and IFR, in the traffic circuit and is managed by the Control Tower, or AFIS. Aerodrome traffic zones are established around airports to protect aircraft during takeoff and landing. The salient features of ATZ are, they typically extend a few miles around the airport, provide a controlled environment for arriving and departing aircraft, require communication with the Control Tower. ATZs are crucial for maintaining order in busy airport environments. The primary difference between the control area, control zone, and aerodrome traffic zone is in their vertical extent and scope. A control zone, CTR, extends from the ground surface upwards to a specific limit around one or more aerodromes. A control area, CTA, extends from a specified lower level, above the ground, to a specified upper limit, often linking airways to terminal areas. And an aerodrome traffic zone, ATZ, is a smaller local zone around a single aerodrome, typically 2 to 5 nm radius, protecting traffic in the takeoff and landing phases, which may exist within a CTR. While an ATZ is often contained within a CTR is broader and focused on instrument procedures for one or more airports, whereas the CTA fills the gap in controlled airspace between the ground-level zones and high-altitude airways.
Having gone through the airspace concepts and building blocks, let's see the important definitions related to the airspace. First, what is a higher airspace? Airspace boundaries are not exactly demarcated vertically over atmosphere. Aircraft are equipped with redundant and accurate altimeters for measurement of altitude during flight. Most of the flight operations happen at altitude where air is dense enough for jet propulsion. The airspace above 46,000 feet, that is 14 kilometers, or 66,000 feet, which is 20 kilometers above, means sea level is commonly referred as higher airspace. The aircraft operations at this airspace are commonly known as higher airspace operations. Secondly, what is an oceanic airspace? Oceanic airspace is the airspace that covers vast areas over oceans. Over oceanic airspace, radar coverage is limited and most of the times unavailable. In oceanic airspace, one-point aircraft rely on satellite communication and position reporting. Two-point aircraft mostly use procedural separation. 3. Requires precise navigation and reporting by pilots. 4. Oceanic airspace is critical for long-haul international flights. Third, what are airways and air routes? Airways or air routes are predefined routes in the sky, like highways in the sky, similar to highways on land. Airways help organize traffic flow and reduce the risk of congestion. Air routes connect different airports and help organize traffic flow. Air routes can be low-level airways, used by aircraft flying at lower altitudes. High-level routes, used by jet aircraft at cruising altitudes. Oceanic routes, used over oceans, where radar coverage is limited. Modern navigation systems use GPS and satellite technology to allow more flexible routing. Fourth, let's see what is a special use airspace. Special use airspace is designated for specific activities or restrictions. These areas are created to separate certain operations from regular air traffic. Special use airspace can be restricted areas, prohibited areas, danger areas, or temporary restricted areas. In restricted areas, entry of aircraft is limited due to potential hazards such as military exercises. In prohibited areas, aircraft are not allowed under any circumstances. In danger areas, activities like weapons testing or aerial exercises may occur. In temporary restricted areas, or the TRAs, are activated during special events, VIP movements, or emergencies. Special use airspace ensures safety by preventing conflicts between civilian and military or specialized operations. Finally, let's see the top 4 challenges in airspace management. 1. Increasing air traffic congestion. 2. Coordination between civil and military airspace. 3. Managing weather disruptions. And 4. Integrating new technologies like drones, VTOL aircraft, etc. Effective planning and global cooperation are essential to overcome these challenges. Hope this video helped you understand that airspace is one of the most important yet invisible component and resource in aviation. Airspace ensures that thousands of aircraft can operate safely and efficiently every day, sharing it without any conflict. Next time you look up at the sky, remember, there's an entire invisible airspace which is managed effectively and efficiently for your safe air travel. Don't forget to like, comment, and subscribe to our channel for more such interesting videos.